Welcome to our deep dive into galaxies. I know you're all really fascinated by these cosmic islands, and we've got a whole universe of information to explore. We're going to be looking at Wikipedia mainly as our source today.
That's right. And, it's more than just about stars and dust. It's about understanding the grand story of the universe.
Yeah. And maybe even its future.
Exactly.
So, we all know galaxies are massive systems held together by gravity. But the thing that really blows my mind is like how many different types of galaxies there are out there and how they form and all this stuff. So we're going to be kind of digging into all of that today. So like, what are the shapes? How many are there? Are they colliding? All that kind of stuff.
And, thinking about our own galaxy, the Milky Way is a great place to start
Mm.
because understanding that helps us understand, the rest of the universe.
I love that.
It's like looking at one tree to understand the forest.
Yeah. Okay, so let's start there. So the Milky Way, our cosmic home, what is it exactly?
Well, it's a barred spiral galaxy. It's about 100,000 light years across. So if you can imagine a giant flat disk with spiral arms, and right in the center, there's a bar-shaped structure.
Okay, I can picture that. So 100,000 light years, that's like incomprehensible. How
Yeah.
many stars are we talking about?
Yeah, so it's estimated to have at least 200 billion stars, all orbiting a central supermassive black hole. And all of that has a total mass of about 600 billion times greater than our sun.
That's a lot of suns.
It is.
Just one galaxy.
Yeah, it's one galaxy among billions.
Okay, wow. So then how do we classify all these different types of galaxies? Like how do we even begin to make sense of all this variety?
Right, so astronomers use a system called the Hubble classification scheme. It was developed by Edwin Hubble back in the 1920s. And it's basically based on a galaxy shape. And that gives us clues about its age and its composition and how it might have evolved over time.
Okay, so let's dive into those shapes then. What are the main categories?
Okay, so we have elliptical galaxies, which are smooth and oval-shaped. They kind of look like giant cosmic eggs. They have very little what we call interstellar matter, which is like the gas and dust that you need to form new stars.
Yeah.
So they're dominated by older stars.
So they're kind of like the retirement homes of the universe.
Uh-huh. Yeah, you can say that.
Okay, cool.
And then within the elliptical category, there's an interesting subtype called type CD galaxies.
Yeah.
These are the real giants.
Yeah.
They can extend for millions of light years across the airway. And we think they form through kind of a process of galactic cannibalism,
Galactic cannibalism.
where smaller galaxies merge together over billions of years.
Wow, so these type CD galaxies are like the result of multiple galaxies kind of colliding and like becoming one.
Exactly. And we see evidence of these mergers in other elliptical galaxies too, like shell galaxies. They have these concentric rings of stars, almost like ripples in a pond. And each ring is thought to represent a different merger event.
Wow, so each ring is like a galactic scar.
Precisely. All right, so moving on from ellipticals, we have spiral galaxies. And those are the pinwheels of the cosmos.
Yeah, like our Milky Way. These are the ones that people think of, I think, when they think of galaxies.
Right. They're beautiful.
Yeah.
And those arms aren't just there to look pretty. They're regions of intense star formation. So they're packed with gas and dust. And as the galaxy rotates, these density waves, kind of like ripples in a pond, sweep through the arms. And that compresses the gas and triggers the birth of new stars.
So the arms themselves aren't fixed. It's like a wave moving through.
That's right.
Yeah.
The stars aren't permanently stuck in the arms. They're actually moving in and out of these density waves as they orbit the galactic center.
That's so cool.
Yeah.
I didn't know that. Okay, and you mentioned earlier that there are different types of spiral galaxies.
Right, so we classify them based on how tightly wound those spiral arms are.
Okay.
So sock galaxies have very tightly wound arms, while sock galaxies have much looser, more open arms. And then, of course, there are barred spirals, like our own Milky Way, with that linear bar structure across their center.
So what forms those bars? And does it affect the galaxy at all?
Yeah, that's a great question. There are still some mysteries surrounding how bars actually form. They might arise from interactions with other galaxies or from instabilities within the galactic disk itself. But what we do know is that they can have a pretty big impact on a galaxy's evolution. So these bars act like funnels. They channel gas and dust toward the galactic center, and that can trigger bursts of star formation and even fuel the growth of the supermassive black hole at the center.
So barred spirals are kind of like the active members of the spiral family.
Exactly.
Cool. Now, besides ellipticals and spirals, are there any other weirdos out there?
Oh, of course. There are a few other intriguing characters in this cosmic drama. So we have lenticular galaxies, which are kind of a hybrid between ellipticals and spirals. So you can imagine a spiral galaxy that has lost most of its gas and dust. So it becomes smooth and featureless like an elliptical, but it still retains a faint disk structure.
Oh, so it's like a retired spiral galaxy.
Yeah, good way to put it.
It's done making stars.
Right. And then we have the real wild cards, the irregular galaxies. These come in all sorts of odd shapes and sizes, and they're often the result of collisions or gravitational interactions with other galaxies. A great example is the Magellanic Clouds, which are visible to the naked eye in the southern hemisphere. They're actually satellite galaxies orbiting our own Milky Way.
Oh, wow. So even our Milky Way has its own little entourage.
It does.
But those aren't the only unusual galaxies out there, right?
You're right. There are also these mysterious objects called dark galaxies, and they're incredibly faint and difficult to detect. We think they might be composed mostly of dark matter with very few stars.
So they're like the ninjas of the galaxy world.
Exactly. And they could hold important clues to understanding the nature of dark matter itself.
Cool.
And finally, we can't forget about the smallest members of the galactic family, the dwarf galaxies. They might be small, containing only a few billion stars, but they're incredibly numerous.
So even though they're small, they play a significant role.
Absolutely. They're thought to be the building blocks of larger galaxies, and they provide valuable insights into the early universe. But that's a topic for another time. Perhaps we should move on to something a bit more explosive.
Ooh, I like where this is going. We've talked about all the different types of galaxies, but what happens when they get a little too close for comfort? I'm talking, of course, about galactic collisions.
Yes, the cosmic fireworks display.
Okay, so I think that sounds like a great place to end this segment. We'll be back after a short break to explore those collisions and dive into the mysteries of active galaxies and even zoom out to see how all these galaxies fit together in this vast cosmic web.
It's going to be an exciting ride, that's for sure.
Welcome back. We've laid the groundwork, explored all the different types of galaxies that populate our universe.
All those shapes and sizes.
Exactly. But now it's time to shift gears a little bit and delve into some of the more dramatic events that shape these cosmic islands. I'm talking about galactic collision.
Yes, the cosmic fireworks show.
Yeah. I mean, the idea of two galaxies each containing billions of stars colliding with each other, it just sounds so spectacular.
It is. And it happens more often than you think.
Really?
Oh, yeah. Galactic collisions are actually a key part of how galaxies evolve and change over time.
So it's not just like a random chaotic event. It's like part of a larger process.
Exactly. Think of it like, imagine two spiral galaxies swirling through space, and their gravitational forces start to pull on each other.
Okay, I'm picturing it.
Right. And as they get closer and closer, those forces become stronger and stronger, distorting the shapes of the galaxies, creating these long streamers of stars and gas called tidal tails.
Oh, yeah, I've seen pictures of those. They're so beautiful, like these delicate wisps of light stretching across space.
Exactly. It's like a cosmic dance, a waltz of gravity and matter. And as these galaxies continue to interact, their gas clouds collide, and that triggers bursts of star formation.
Wow, so these collisions, they're not just destructive events, they actually lead to the creation of new stars.
Absolutely. It's a cycle of creation and destruction. And sometimes those collisions can be so intense that the galaxies actually merge together completely.
Wait, so two separate galaxies can become one?
That's right. Over billions of years, they slowly coalesce their stars and gas intermingling until they form a single larger galaxy.
Wow, that's mind-blowing. So, what happens to the supermassive black holes at the centers of these galaxies?
Oh, that's a great question. So when galaxies merge, their central black holes also eventually merge, forming an even more massive black hole at the center of the new galaxy.
It's like black holes on a shopping spree buying up all the smaller ones.
Yeah, something like that. And as these black holes merge, they release tremendous amounts of energy, creating some of the most powerful events in the universe.
So it's not just stars colliding, it's like everything is colliding.
Pretty much. And, speaking of collisions, we're actually on a collision course with our nearest galactic neighbor, the Andromeda Galaxy.
Wait, what? We're going to collide with Andromeda.
Yep. But don't worry, it's not going to happen for another 4 to 5 billion years.
Okay, well, that's a relief, I guess. But what will happen when we do collide?
Well, current simulations suggest that the Milky Way and Andromeda will merge to form a giant elliptical galaxy. So our spiral galaxy with its beautiful arms will eventually become a smooth, round elliptical.
So it's kind of like galaxies evolving from these elegant spirals into these more mature ellipticals.
In a way, yes. And it's a reminder that the universe is constantly changing and evolving. Nothing is permanent, not even the grand structures of galaxies.
It's kind of humbling, isn't it, to think about these cosmic timescales and these vast processes that are shaping the universe around us.
It is, and it makes you realize that we're just a small part of this grand cosmic story.
Yeah.
But, there's so much more to explore. We've talked about galaxy collisions, but what about these incredibly energetic galaxies, those with active galactic nuclei, or AGNs as we call them?
Oh yeah, AGNs. I've heard of those. Aren't those the galaxies that are like super luminous, like they're shining brighter than a billion suns?
That's right. AGNs are powered by supermassive black holes that are actively feeding on gas and dust. And as this material spirals into the black hole, it heats up and emits incredible amounts of radiation across the entire electromagnetic spectrum.
So it's like a cosmic light show, a beacon shining from the heart of a galaxy.
Exactly. And AGNs come in different varieties depending on the angle at which we're viewing them and the properties of the accretion disk around the black hole.
So there are different types of AGNs?
Yes, there are Seyfert galaxies, which have very bright cores, and their spectra show evidence of highly ionized gas. Then there are quasars, which are the most distant and luminous AGNs. They're thought to be powered by the most massive black holes in the universe. And then we have blazars and liners, which are other types of AGNs with their own unique characteristics.
It's amazing how these supermassive black holes can create such a variety of phenomena. It's like they're the conductors of a cosmic orchestra.
A very apt analogy. And, speaking of cosmic wonders, we've been focusing on individual galaxies and their interactions. But what about the bigger picture? How are all these galaxies distributed throughout the universe?
Yeah, that's a great question. We've zoomed in on the details, but now I want to zoom out and see the whole picture. How does it all fit together?
Well, that brings us to the topic of large-scale structure, the cosmic web that connects it all.
Okay, a cosmic web. Now I'm really intrigued. Tell me more.
Welcome back to our cosmic journey. We've been exploring galaxies and, their different shapes and their collisions and even these crazy AGNs. But now I want to zoom out. I want the big picture. How does it all fit together? How are all these galaxies distributed throughout the universe? Is it just random?
Well, it's not random at all. It's tempting to think of galaxies as just scattered randomly throughout space, but the reality is much more organized and kind of mind-blowing. Galaxies are actually arranged in these groups and clusters and even superclusters, forming this vast interconnected network we call the cosmic web. A cosmic web. Okay, I'm trying to picture this in my head. What are these groups and clusters and superclusters?
So imagine it like this. You have groups of galaxies, which are like the small towns of the universe. They typically have a few dozen galaxies all bound together by gravity. Our own Milky Way is actually part of a group called the local group.
So the local group, that's like our little neighborhood.
Exactly. And then these groups themselves are not isolated. They cluster together, forming larger structures called galaxy clusters, which can contain hundreds or even thousands of galaxies.
So it's like towns make cities and cities make huge mega cities.
Right. And then those galaxy clusters group together into even larger structures called superclusters, which are like the ultimate cosmic metropolises. They're vast collections of galaxy clusters spanning hundreds of millions of light years.
Wow. So it's like galaxies within groups, groups within clusters, clusters within superclusters. It's like a cosmic nesting doll. How do astronomers even begin to map something like that?
Well, it's a huge challenge, but they use these large-scale galaxy surveys to measure the positions and distances to millions of galaxies and create these three-dimensional maps of the universe.
So it's like they're creating a giant cosmic atlas.
Exactly. And these maps don't just show us where the galaxies are, they also reveal these vast empty regions called voids where there are very few galaxies.
Voids. So these are like cosmic deserts.
Pretty much.
Yeah.
They can be enormous, spanning hundreds of millions of light years. And it's kind of amazing to think about, these huge empty spaces separating these bustling cities of galaxies.
It's like the universe is this giant sponge with all the matter clumped together in these filaments and sheets.
That's a great analogy.
Okay, so we've got galaxy groups, clusters, superclusters, voids. But at the beginning of this deep dive, we talked about how there are hundreds of billions of galaxies in the observable universe. How do we even know that?
Well, it's based on observations and calculations. Astronomers use deep field images, like the famous Hubble Deep Field, where they point the telescope at a tiny patch of sky and just count all the galaxies they can see.
Yeah, I've seen those pictures. It's amazing how many galaxies are packed into this tiny little region of sky.
Exactly. And then based on that count, they extrapolate to the entire observable universe.
It's kind of mind-boggling to think about those numbers, like hundreds of billions of galaxies, each containing billions of stars, all connected in this incredible cosmic web.
It is. It really puts things into perspective, doesn't it?
It does. It makes you realize how much we still don't know about the universe.
Exactly. There's always more to discover, new mysteries to unravel, and new wonders to explore.
Well, I think that's a great place to wrap up our deep dive into galaxies. We've covered a lot of ground today, from the different types of galaxies to their collisions, their evolution, and even this incredible cosmic web that connects it all.
It's been a fantastic journey.
It has, and I hope you've enjoyed it as much as we have. So until next time, keep looking up at the stars and keep exploring the wonders of the universe.
And keep asking questions.
This is The Deep Dive signing off.